All right, good morning. Unit 9, complete surface area and volume of cones. For our prior knowledge, it says find the height of the cone. And you know when we find height, that's where Juan comes in. So the radius is 7. Let's go ahead and draw that in. And if Juan was up here and dropped his little rock straight down, we would have perpendicular. So if we wanted to find A, that altitude, we just use Pythagorean theorem. So what is that? 25 squared minus 7 squared. Plugging that in our calculator. A is exactly 24. Remember what 25 is? That side, that lateral side. Remember, that's our slant height. And we're going to use the letter L for slant height. And L is 25. R equals 7, and A equals 24. All right. Not a big fan of giving formulas, but I'm just giving the formula for surface area of a cone. So for surface area of a cone, we're going to have that circle down below. See how the net over here to the right is showing what the cone looks like? This is a sector. It used to be a whole circle. And so basically what we're doing is we're going to find the area of a sector and area of a circle. And that area of the sector is that pi RL. So surface area of a cone, we just plug into the formula. Pi r squared, which is area of the circle, and pi RL, which is the area of the sector. The only thing you need to pay attention to is did I give you the diameter or not? And we'll also work backwards. So here we go. Let's plug in. We're going to find the surface area for each of these cones. So remember, surface area, pi r squared, the area, plus pi RL, the sector. So our surface area is pi 2 squared plus pi 2 times 6. Oops, why did I put a r squared there? We already have that. 2 squared. 2 squared is 4. 2 times 6 is 12. So 12 plus 4, surface area, 16 pi 8 squared. You could plug it into your calculator, but I'm not going to do that right now. Here we go. Here's another little cone. Surface area. Pi 4 squared, so 4 squared, 16. 16 pi plus pi times 4 times 8, and 4 times 8 is 32. 32 pi for the R and the L. And so adding that together, surface area, 48 pi centimeters squared. Pretty easy. So plug and chug. This one, so going back up here, remember where you had to find the altitude in the prior knowledge problem? So this is going to be the trick with cones like it was in pyramids. You might need to use the Pythagorean theorem to find the missing side. So let's look at this. How do we determine the surface area of a cone if they've given us the altitude? And the diameter. If the diameter is 12, what do we know? Right off the bat, let's tell ourselves radius is 6. All right, so here's my cone. Oops. Start with the cone before we put in the altitude. These are kind of fun to draw. I do a dashed here, and a solid here, and in the middle, I draw my radius. My radius is 6, and my altitude, A, is 8. And let's not forget 1. So there's 1. We've got a right triangle here. So boom, let's just redraw it over here. We've got 8, 6, and if you remember from similarity, this is similar to the 3, 4, 5. That means our slant height, L, is 10. So for surface area, the altitude's great because that gives you the height of the cone, but we want the slant height. So here we go. We're going to plug it in. Pi r squared, surface area, pi, radius squared, 6 times 6, 36, plus pi RL, 6. Now is it 6 times 8 or is it 6 times 10? Well, it's a good thing that we wrote it out here. 6 times 10 is 60. So surface area is 96 pi. What are we talking about? Inches squared. Exactly. Okay. Here we go. Just like yesterday. We're going to watch a little video. Stop share. There I am. And I gotta go share screen. So, and back to me, and then back to our classwork. Here we go. So little experiments done by somebody else for the sake of time. The number of cones needed to fill a cylinder. How is the volume of a cylinder related to the volume of a cone with the same base and same height? So comparing the height of the cylinder to the height of the cone, what did we notice? Those were the same. And in the video, comparing the base, meaning the circle, the base of the cylinder to the base of the cone, what did you notice? Those were the same. So filling the cone with water, how many cones filled the cylinder? No arguing, it's 3. So suppose a cone has a volume of 12 cubic units. What would be the volume of the cylinder that has the same base and the same height of the cone? Well, the volume of the cylinder equals 3 volume of cones. So the volume of the cylinder equals 3 times 12, which equals 36 units cubed. Working backwards, suppose the cylinder has a volume of 210 cubic units. So we could say 210 equals 3 volumes of cones. And we can divide the volume of a cone, in this case, 210 divided by 3, 70 units cubed. So the equation for the volume of a cylinder, remember the volume of a cylinder equals the area of our circle base times the height, or volume equals pi r squared h. So if we want to know what's the volume of a cone that has the same base and same height as this cylinder, volume of a cone, what do we do up here to find the volume of the cone? Oh, we divide it by 3. Well, we can find the area of the circle base, multiply by the height, and divide by 3, or we can use this handy little formula, pi r squared h divided by 3. Area of the circle base times the height, we just want 1/3 of it. So applying that, each pair of figures below has the same base dimensions and height. Use the given volume to find the volume of the other figure. So if we know that the volume of the cylinder equals 156 inches cubed, the volume of the cone is 1/3 of that. The 156 divided by 3 is going to be 52 cubic inches. All right, let's look at a couple practice problems. Determine the volume of the cone. Well, volume, pi 6 squared times 15, that's the prism, divided by 3. We're just going to leave everything as exact. So I'm going to say volume 36 times 15 divided by 3, 180 pi centimeters cubed. Uh-oh. What were we given here? We were given L. We need A. And so in this case, Pythagorean theorem, quick Pythagorean theorem tells us 30 squared minus 13 squared. We're going to get approximately 27. So in this case now, our volume is pi 13 squared times 27 divided by 3, which means our volume is going to be 1,521 pi units cubed. What will have a larger volume? A cone with a diameter of 12 feet. So here, let's draw a cone. Boom, boom. Radius. That's 12. And a height of 23, or a square pyramid that also has a height of 23 and a side of 12. Well, here's the thing. They have the same sort of footprint, right? A footprint where I can put a circle inside where my diameter is 12. So what do you think holds more? All right, the volume is pi, radius is 6, so 6 squared times 23 divided by 3. That volume, plugging it all into the calculator this time, is 867.08 feet cubed. Do you think the square pyramid is going to be more? Volume. Remember, that's going to be the area of the base times the height divided by 3. The base is the square, so 12 squared, times the height of 23 divided by 3. Our volume here, 1,104 feet cubed. It's going once.